All right, so when it asks how many solutions does the system have, there's going to be a couple of special cases. The special cases are when it's exactly the same line, in which case every set of coordinates that solves one of the equations is going to solve the other one. That means if you graphed it, the lines are right on top of each other. It's essentially the same line. And there's an infinite number of solutions because since they share all points, every single one of the points, the infinite number of points along the line, will solve them both. Okay? Those will have the same slope and they'll have the same intercept if written in slope-intercept form. Okay? The other special case is where they have the same slope but a different intercept, which means that they're parallel. There's no place where they intersect, and since the point of intersection is the coordinates are the solution, then there's no set of coordinates that will solve it. Okay? Both of those situations, when you write them into slope-intercept form or you're able to examine the slope, you have the exact same slope. Okay? If you have the exact same slope and different intercepts, then they're two different lines that don't intersect. They're parallel and there's no solution. Okay? If they have the same slope and the same y-intercept also, then it's the exact same line. And there's infinite solutions. Okay? So either no solution or infinite solutions, they both have the same slope. One solution is just they have different slopes and they're going to intersect once. Okay? For your purposes, none of these linear functions, two linear functions, will have two solutions. So this answer right here, B, is not going to be true for linear functions. Okay? So why do they include that? Well, let me just give you a little scenario here before I start doing this. Okay? If they weren't both linear functions, let's say one of them was a quadratic function and it was a parabola, okay? And then the other one was linear, or some other equation where they crossed twice, right? They could intersect twice. And the point where they intersect here and here, those would be two solutions, okay? But in order for that to happen, you have to have at least one of the equations representing a curve and not a straight line. Otherwise, you can't take two straight lines and intersect them more than once if they cross, right? So for linear functions, and you're going to be seeing this question asked for two linear functions, you know that it's either going to be one solution, no solutions, or an infinite number of solutions. So we already can straight away cross out the two solutions case if they're both linear. So let's cross that out right away. Okay? Now what we're going to do is we're going to take these equations and we're going to write them in slope-intercept form. And let me write up here on the top, slope-intercept form, remember, is y equals mx plus b, where we can check out what the slope is. Okay, and remember, if you write it this way and there's different slopes, then we know they're going to intersect once. If it's the same slope, then we know it's going to be a special case, and then this b value will tell us if it's a special case, is it the exact same line because they have the same y-intercept, or do they have different y-intercepts and they're parallel? So let's rewrite this first equation, x equals negative 4y plus 4. And the way that I'm going to rewrite it is I'm going to put the y's on the left-hand side. So we get x plus 4y equals 4. And then I'm going to subtract the x away from both sides. And we get 4y equals negative x plus 4. The last thing I want to do, because remember we wanted to just say y equals, not 4y equals, is to take every term and divide by the same number. Okay? Oops. And what we get then is y equals, remember there's an invisible 1 behind the negative, between the negative and the x, so negative 1. So we've got negative 1/4 x, 4 divided by 4 is 1. Okay? That's one of our equations. And I'll underline that up here in this one. That's that one. Okay? And then I will take the second equation, 2x plus 8y equals 8. And I'm going to solve for y equals, same thing that I just did. Minus 2x minus 2x. And we get 8y equals negative 2x plus 8. And dividing by the number in front of y, we'll just get down to y equals. Sorry for the delay, I had to fix something there. And when you do that, you get y equals negative 1/4 x plus 1. Aha! They are the exact same equation. They have the same slope and they have the same intercept. You can see they are the exact same line. So, any point, any set of coordinates, x and y, that solves one of them is going to solve the other one, naturally, because they're the same line, just written a different way up top there. Okay? And so there's an infinite number of solutions to this, because anything that solves one will solve the other, and there's an infinite number of points along the lines that will solve them, so infinite solutions.